This is a quick review of compound probability and tables. When rolling two six-sided die, what is the probability that the sum of the two dice will be larger than 10? I'm going to come back to that question. In this lesson, you will learn how to find the probability of compound events by creating a table. So if we look at a fair coin when it is tossed twice, list all the possible outcomes. Well, we could list it with a tree diagram, which will lay out exactly how many outcomes there are, clear for us to see, or we could make an organized list. Another possibility, though, is to create a table. So let's use a table to do our problem from the very first part of the video. What is the probability that the sum of the two dice will be larger than 10? Well, we create our table and lay out the possibilities of one die on top and the possibilities of the other die on the side. Then list out all of the possible combinations and then add them up to show our sums. Then, when we think about the probability, we can actually highlight the table and say, all right, there's 11, 11, and 12. That means there are 3 out of 36 that would result in greater than 10, which could reduce down to 1/12. In this lesson, you've learned how to find the probability of compound events by creating a table. Let's do some guided practice. Megan and Ryan want to roll 2 dice to see who will do the dishes. They decide that any sum of 6 or below means Megan does the dishes, and any sum of 7 or higher means Ryan does the dishes. Is this game fair? Explain why or why not. Well, if we create a table, just as we did for the previous problem, and we listed out all of the combinations and then found all their sums, when we look at Megan, we could highlight each of the numbers that would result in her winning, and then we could highlight the numbers that would result in Ryan to win. And what we find is that Megan has a probability of winning of 15 to 36. There are 36 outcomes, but only 15 would allow her to win, while Ryan has 21 out of 36. He has 6 more chances of winning than Megan does, so it is not a fair game. He clearly has an advantage. Fair or not fair? Here is a game of chance for 2 players using 2 dice of different colors. Each of the 2 players rolls a die, and the winner is determined by the sum of the faces. Player A wins when the sum is 2, 3, 4, 10, 11, or 12. Player B wins when the sum is 5, 6, 7, 8, or 9. If this game is played many times, which player do you think will win more often and why? Make a table representing all the possible outcomes. So I recreated the table from the previous problems, and I highlighted the ones that would be player A, and those are the ones in yellow. The remaining ones are for player B. Clearly, you can see that player B has a large number of outcomes that would allow them to win versus player A. So even though player A has more ways of winning, or rather more sums that could result, 6 versus 5, the 5 that player B has results in more possible ways for it to happen. So player B would have the advantage, and it is not a fair game. Quick quiz. Joe is playing a game in which he must roll a die and toss a coin. What is the probability he will roll a 6 and toss a heads? Well, we'd find it to be 1/12. There are 12 possibilities from our list, but only one allows for a heads and a 6. Paul is at a game show and wins if he can toss a coin and get heads and spin a C on a spinner that has 3 equal sections. What is the probability that Paul will win? Well, the probability that he will win is only 1 out of 6. And I get that from my organized table.